Hi guys, today we're going to go through how to do long division of polynomial functions. So the first thing that I'm going to do is just quickly refresh the process of long division before we jump into this question. So let's start off with a really simple example that you guys would already know the answer to or already know the solution to. So if we did 396 divided by 3. So when we write this using long division, we're going to put the number that we're dividing underneath this divide symbol here, or this box symbol here, if you want to call it that. And we're going to put the divisor, so the number that we're dividing by, on the outside. Okay, so when we do long division, what we're really doing is we're following a very specific process. So we're going to divide, then we're going to multiply, then we're going to subtract, and if we need to, we're going to add. So I'm going to put a circle around that last little operator there. So when we do this, the first step that we're going to do is we're going to say, okay, so how many times does 3 fit into 3? So that's my divide step. So 3 divided by 3 is 1. Now what I'm going to do is I'm going to multiply what's out the front by up the top here. So 3 times 1 makes 3. Next, I'm going to subtract the two values. So that's going to have a remainder of 0. So in this case, because I've got 0 left over, I'm going to add the next digit. And I don't mean add as in we're adding the hundreds columns and the ones columns or anything like that. I literally just mean we're going to add this down here. So we're just bringing it down. So now what we're going to do is we're going to work from the bottom here. So we're going to repeat these steps. So 9 divided by 3 is 3. 3 times by 3 is 9. And when we subtract the 2, we get a difference of 0. So next I'm going to bring down my 6. So that's my add step there. So 3 fits into 6 2 times. 3 times 2 is 6. And then I'm going to have a remainder of 0. So I would write remainder of 0. Okay, so that's how we do long division. So I'm going to use that general process to help us to do a polynomial function now. So just like we saw before, we're going to put the function that we are dividing underneath that box symbol. So we're going to have x cubed plus 2x squared plus 3x plus 4. And that's all going underneath that box. And we're going to put the divisor, so x minus 3, out the front. Now with polynomials, we're going to follow the same process, but we're going to have to do this a little bit differently. And I'm not actually going to include this add symbol on the bottom here. So with this, rather than using the digits, we're going to just use the x terms when we first divide. So x cubed divided by x is going to be x squared. X take 3, we're going to multiply this entire thing now by x squared so that we have x cubed minus 3x squared. So it's a little bit different to the last process. Now we're going to subtract the 2. So x cubed take x cubed is 0. 2x squared minus negative 3x squared is going to make 5x squared. Now in this case, because I can divide into this, it doesn't have a remainder of 0 or anything like that. I don't need to add down the next term. So this is why I'm not putting that addition symbol there, because I can work straight from here. So x fits into 5x squared, 5x times. So that's my divide. 5x times by x take 3 is going to be 5x squared take 15x. And now we're going to subtract. So 5x squared take away 5x squared is going to be 0x squared. And 3x take away negative 15x is going to be equal to 18x. So again, I don't need to bring down the next digit because I can work straight from here. So let's repeat the process. 18x divided by x is going to be 18. X take 3 times 18 is going to be 18x. And then, 20 times by 3 is 60. And then take away 6 from that. So that'll be 54. So 18 times 3 is going to be negative 54. Okay, so now that we've done our multiplication, let's subtract. 18x take 18x is 0. And then we're going to have 4 take away negative 54 to give me 58. So x will not fit into 58, so this is going to have a remainder of 58. So that would be our solution with a remainder of 58. Let's go ahead, let's do another example. So this is written a little differently, but it's basically the same process because fractions really just mean to divide. That vinculum or that line in the middle, when we replace this with numbers, that's when it becomes some sort of fraction. So that's a cool little fun fact just to let you know. So these dots are replaced with polynomials in this case. Okay, so let's go ahead and let's draw this under our box symbol and let's pop our divisor on the outside. So we have x cubed take 4x squared plus 2x take 1 under the box and then divided by x plus 1. So again, I'm just going to put my little symbols here to remind me and to help me. So when we're doing the divide step, we're just looking at the x's. And when we do the multiply, we're going to use the whole divisor. So x cubed divided by x is going to be x squared. X plus 1 times by x squared is x cubed plus 1, oh, I don't need to write that, x squared. And then I'm going to subtract. So x cubed take x cubed is 0. Negative 4x squared take x squared is going to become negative 5x squared. So let's repeat the process. X fits into negative 5x squared, negative 5x times. Negative 5x times by x plus 1 is going to make negative 5x squared minus 5x. So that's our divide and our multiply. Next, we will subtract. So 5x squared take away negative 5x squared is 0. And 2x take away negative 5x is going to become 7x. X fits into 7x. Positive 7 times. 7 times by x plus 1 makes 7x plus 7. And then to subtract, 7x take 7x is 0. Negative 1 take 7 is going to become negative 8. X doesn't fit into negative 8, so we're going to have a remainder of negative 8. So that's how we use long division of polynomials, and this helps to simplify polynomials. A lot of people ask me, oh my gosh, miss, when are we going to do this? Honestly, there are other methods that you could use to divide through by a polynomial, and there are simpler methods that we could actually use to determine what the remainder is going to be. So in the next video, what I'm going to talk about is I'm going to talk about the factor remainder theorem. And I'm actually going to do these exact two questions, but I'm going to show you how using the factor remainder theorem can actually give you these remainders without having to perform this whole process of long division. And the reason we would do that is because we're specifically looking for factors. All right, guys, so hit me up in the next video looking out for the factor remainder theorem. Bye, guys.